We now want to talk about the number e. The number e is an irrational number that is approximately 2.7182818 blah 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 blah. On your calculator you should have an e to the x key. You might have to access it using the second or shift key on your calculator. Most of your calculators have you type the exponent and then hit the e to the x key, but some of the newer ones, and actually this is becoming more so, have you do the sequence backwards. So if you look on the TI Thury XS and you look at the third button down from the second key, it's an LN button, and notice in green is your E to the X. That is your E to the X key. E is kind of like what pi is in mathematics. So if I need to evaluate this, on this calculator, what we do is we hit our second key. See if I can get up here. Second, and then the LN key. And notice it gives me E and already pops me up in the exponent. Then hit enter. If I need to e to negative 1.2, I do second ln negative 1.2, hit enter. And for that last one, I would do 2 second ln. That gets my e, and that gives me my number here. So make sure you can do this on your calculator. You'll need to know how to do that on your calculator. Now keep in mind exponential functions are one-to-one. So if you know if my bases here are the same, you can just set your exponents equal to each other and solve. So let's look at some problems involving that. So go ahead and take a few minutes. Go ahead and pause the video and make sure you can calculate these on your calculator. So let's just verify. You get second ln2. For round the 4 decimal places, that 0 becomes a 1. So this will be approximately 7.3891. Let's go ahead and do our e to the negative 3. For decimal places, that would be 0.0498. For this one, we do second ln, second squared key, type my 7, hit my right arrow key a couple times, and hit enter. And so that would round off, and let me slide this over. To 14.094, I guess it would stay 0. And we just did e to the pi a little while ago, but let's just practice. Second ln, second, actually no second here, just my pi key here. To 3.1407. So again, just make sure you can get these on your calculator. That's going to be important. So now we want to talk about interest. So we'll go back a few pages. When a person gets a loan from the bank, that person has to pay back the amount of loan plus interest. The interest is the fee that the person has to pay for using money from the bank. In the same way, if a person opens a savings account, the payback pays that person interest since the bank gets to use that person's money while it's in the account. The formula for simple interest is I equals PRT. The interest, I, is the fee paid for borrowing money. The amount of the loan or in the savings account is called the principal, P. The interest rate, R, is the rate that interest is charged on the amount borrowed converted to a decimal fraction. The rate is usually given as a percentage and is assumed to be a yearly percentage unless it states otherwise. The amount of time T is the length of time in loan in years. So for instance, where the interest rate is given as a monthly interest rate or a daily interest rate, then correspondingly your time would need to be in months or days. And the amount A is the amount that you pay back as principal plus interest. Now, compound interest, that occurs if an account earns interest during a period of time, that interest is then added to the principal. During the next cycle, the new principal is the old principal plus the interest earned during the last cycle. Thus, at the end of the next cycle, the amount not only earns interest on the original principal, but also the interest earned on the last cycle. We say that interest is compound. Thus, compound interest is interest earned on the principal and on the interest earned previously. How often interest is calculated depends on the length of cycle or payment period. So here are some common payment periods. If interest is compounded annually, then it's once a year, then my value of n would be 1. Semi-annually is twice a year, so n would be 2. Quarterly is 4 times a year, so n would be 4. Monthly would be 12 times a year, n would be equal to 12. Weekly would be 52 times a year, so n would be 52. Daily would be 365. Now, just as a caveat on that, some financial institutions do not like the fact that some months have 28 days, some have 30, some have 31. Occasionally we have a month that has 29 days. So they might be using what's called banker's rule. So they might define 1 month as 30 days and 1 year as 360 days. So you might see them in some textbooks using 360 instead of 365 when they do this calculation. It's very important if you're ever getting a loan out, like one of those interest-free loans for 1 year, you have to read the terms of the contract. Make sure they're not talking about 360 days. That's going to be a little bit less than a year. You have to pay attention to when that date actually cuts off. So we have 2 compound interest formulas. If the principal P is invested at an annual rate R compounded n times a year for t years, the amount of A, the future value, will be A equals P, parentheses 1 plus R over n raised to the nt. That's our future value. Note that R needs to be converted to a decimal in the formula. The principal present value that needs to be invested into an annual growth rate, interest rate, are compounded times a year for t years, so it grows to the amount A is P equals A 1 plus R over n raised to negative nt. It's basically the same formula. What you do is you divide both sides by this. With that denominator, we bring it up into the numerator. Again, R has to be converted to a decimal in the formula. We also have one that's compounded continuously. So if principal P is invested at an interest rate compounded continuously for t years, that means you're always continually compounding, calculating interest. The amount A will be A equals P e to the RT, where E is that 2.71 blah 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 number. And then for present value, A and P are switched around, and my exponent's negative. Just like the other formulas, R needs to be converted to a decimal fraction. So let's go back into the workbook. And here, just kind of a quick reminder of some of our formulas here. So we want to suppose that 15,000 is invested at 2.5% interest under the following compounding options. Determine the amount in the account at the end of 7 years for each option. So let me first write down our formula if it's compound annually. So 15,000 is my principal. So I'm going to plug that in. My percentage here, 2.5%. I need to write that as 0.025. So I'm going to plug that in here. Here N is 1 because it's annually. So I put a 1 here and a 1 here. And then my time here is 7 years. So let's go ahead and we're going to enter that whole thing into our calculator. So I'm going to have 15,000. 1 plus, to our fraction key, 0.025 over 1. Parentheses, caret key, 1 parentheses 7. Hit enter. And then we want to round to the nearest cent. So that'd be $17,830.29. Now, number 8 is really almost the exact same calculation. The only thing we're changing is n. N is now 12. But in terms of writing this out, everything else stays the same. I'm going to still use 0.025. This time I'm going to be using 12 for n. My years is going to be 7. Now, I don't want to retype this whole thing here, so we're going to cheat a little bit. So what I'm going to do is I'm going to hit my up arrow key until I've got that thing highlighted. Hit enter. Notice it puts it down. So now I can just kind of arrow over here, change that 1 to a 12. And I'm going to just change this part, 12 parentheses 7. And so then rounding this off, this would be $17,865.44. Sorry about that. I forgot to put my phone on vibrate. All right, let's try the next one. Compound concordance. It's the same formula, but now I'm doing when n equals 4. So we're going to have our 15,000. Our 1 plus, this is still going to be 0.025, but now my n's going to be 4, so I'm going to have a 4 here and a 4 here, and 7 up here. Alright, so let's go ahead and grab that formula. I'm going to go up a couple times here. Grab this one, since I have a single digit for n, and I'm going to just change those 1s to 4. So I'll change that to a 4, and then change that to a 4. And now round off. That would be $17,858 and 96 cents. So for 7, 8, 9, they're giving me what's compounded. I'm just using the formula. All I'm doing is change the value of n. For last one's compounded continuously, that's when we have to use the other formula. A equals P e to the RT. So here I go, A equals, I'd still do my 15,000. E, my R here is 0.025. And my T is 7. So whenever they say continuously, that's when you use the second formula. So let's put that into our calculator. That'd be 15,000 second ln 0.025 times 7. Hit enter. And then we just round it off. $17,868.69.